After age 50, many people notice thinking feels slightly slower than before.
This change rarely appears suddenly and usually develops gradually over several years.
Factor crashings. Most assume aging alone explains these differences in memory and concentration.
However, the brain depends heavily on consistent biological support from daily nutrition.
Although the brain weighs only about 2% of body mass, it consumes enormous energy.
Nearly 20% of oxygen and fuel entering the body is used by brain activity.
Because demand is high, small nutrient shortages affect cognition earlier than other organs.
Instead of dramatic symptoms, the brain usually sends subtle functional signals first. Today we explore 3 nutrients strongly associated with long-term cognitive stability.
The brain is composed largely of fat, especially within neuronal cell membranes. One fatty acid, called DHA, forms a major structural component of gray matter.
Neurons communicate by electrical and chemical signals across specialized connections called synapses.
Membrane flexibility determines how efficiently signals move between nerve cells.
When membranes contain sufficient DHA, receptors respond quickly and communication remains stable. If DHA levels decline, signaling gradually becomes slower and less consistent. Omega-3 fatty acids also influence inflammatory regulation inside brain tissue.
Long-term neuroinflammation has been associated with age-related cognitive decline patterns.
Omega-3 helps maintain cellular integrity and moderates inflammatory signaling pathways.
Large population studies repeatedly connect fish consumption with healthier cognitive aging outcomes.
Common sources include salmon, sardines, mackerel, walnuts, and chia seeds.
These foods support structure and maintenance rather than producing immediate mental stimulation.
Another important nutrient for the brain is choline, often less discussed in daily nutrition.
Choline is required to produce acetylcholine, a key neurotransmitter involved in memory processing.
Every time the brain forms or retrieves information, acetylcholine signaling participates directly.
Learning, attention, and mood regulation depend on stable cholinergic communication pathways.
Without adequate choline intake, neurotransmitter production becomes limited over time.
Reduced acetylcholine availability may relate to slower recall and decreased concentration ability.
The hippocampus, essential for forming new memories, uses acetylcholine extensively during activity. Maintaining sufficient choline intake helps stabilize mental processing efficiency in older adults.
Dietary sources include eggs, poultry, beef, soybeans, and several legumes. These foods provide building material rather than temporary cognitive stimulation effects.
The B vitamin group supports both vascular and neurological protection mechanisms. Vitamin B6, folate, and vitamin B12 regulate metabolism of the amino acid homocysteine. High homocysteine levels are associated with damage to blood vessel lining tissues. Healthy vessels supply oxygen and nutrients necessary for stable brain function.
These vitamins convert homocysteine into safer compounds through natural enzymatic reactions. Vitamin B12 also maintains myelin, the protective insulation surrounding nerve fibers. Myelin allows electrical signals to travel rapidly along communication pathways.
When myelin integrity declines, processing speed and coordination gradually slow.
Absorption of vitamin B12 commonly decreases with aging due to digestive changes.
Individuals following strict plant-based diets may require careful monitoring of intake.
Adequate levels support neurological stability rather than enhancing performance beyond normal limits.
Omega-3, choline, and vitamin B are not specialized enhancement supplements.
They function as basic materials maintaining structure, signaling, and protective mechanisms.
The brain rarely deteriorates suddenly. Imbalance develops slowly over many years. Consistent nutritional support helps maintain function long before noticeable decline appears.
Small daily habits often influence long-term brain performance more than dramatic interventions.
Understanding these foundations allows better decisions for healthy aging and cognitive clarity.